Hello everyone, today let's take a look at Quantipus number 83, another conditional probability question. So looking at this question, 36% of families own a dog. Okay, let's draw a circle and we have 36% probability mass in here. This will be our dog circle. Now it tells us that 30% of families own a cat. So let's draw a cat circle here, which will have 30% probability mass. Now it tells us that 22% of the families that have a dog also have a cat, and that does not mean that in here is 22%, right? That would be the case if it said 22% of families own both a dog and a cat, but it doesn't say that. It says of the ones who have a dog, there's 22% that also have a cat. So if we let D be the event that a family has a dog and C be the event that a family has a cat, then it's saying that the probability of C given D is equal to 22%. Because we're saying when I know for a fact that a family has a dog, then 22% of the time they will also have a cat. So if I know for a fact that D happened, that means I restrict my outcome space to only the events where D happens. And now we look at it from a new point of view. And now that I know that I'm in this green circle, the odds that I have a cat are 22%. So I take the cat area of this green circle, which is all of this right here. So let's call this region in here X. And then the probability that I have a cat, given that I'm within this region, is just going to be X over 0.36, right? The area of the green circle. So we know that this is equal to 0.22, and then we can just solve for X by multiplying each side by 0.36. And when I do that, I get 0.0792 or 7.92%. Okay, so that basically told us that 7.92% of families own both a dog and a cat. So now the actual question's asking if a family's chosen at random and found to have a cat, then what is the probability that they also own a dog? So this is just the probability of a dog given that they own a cat. So they're saying if we know for a fact that a family owns a cat, so we restrict our outcome space to just this green bubble here, then what is the probability that they also own a dog? And again, that's just going to be this shaded region here, right? The overlap between cat and dog. But we already calculated what that was, right? It was 0.0792. So the probability of a dog given that they own a cat is just going to be X, which was 0.0792, divided by the total area of our restricted new space, which is this green bubble, and we know it's 0.3. And when I take X on 0.3, I wind up with a final answer of 0.264 or 26.4%. If we wanted to solve this just using numbers and forget about the Venn diagram, then the probability of D given C, which we're trying to solve for, well, we know that's just equal to the probability that D and C both happen divided by the probability of C happening in general. And so since we know that this is equal to this right here, that basically tells us that the probability of D and C both occurring is equal to the probability of D given C times the probability of C, right? Just by rearranging the equation. And we're given the probability of C given D, which we know is equal to the probability that C and D both occur again, divided by the probability of D, right, our restricted space. So again, we can rearrange this equation and get the probability of C intersection D. Well, that's just equal to the probability of C given D times the probability of D. And if you notice, well, these two terms are obviously just the exact same thing, right? So we can set them equal to each other, and then we get that the probability of D given C times the probability of C is equal to the probability of C given D times the probability of D. And what were we originally trying to solve for? Well, it was this right here, the probability of D given C. That's what we were trying to solve for. So let's put that on the left-hand side and everything else on the right. So then we get that it's equal to the probability of C given D times the probability of D on the probability of C, all three values which we were given. Yeah, so this is just Bayes' formula right here. It's basically exactly what we did up here. We were just visualizing it using Venn diagrams. And if you just plug in all the numbers that we were given, right, we were given the probability of C given D is 0.22. We were given the probability of D is 0.36, and the probability of C is 0.3. So all we have to do is just go 0.22 times 0.36 on 0.3, and then we'd get the exact same thing.